Hello everybody. Thank you for joining us on today's official Appeon webinar. Today's webinar focuses on PowerBuilder 2017 R3, which is hot out of the oven. You're going to get a first-hand look at the enhancements we've made to PowerBuilder over the last 6 months. Typically, an official Appeon webinar is conducted by Appeon staff, but today we're honored to have community guest and Appeon MVP Bruce Armstrong. Many of you know Bruce Armstrong, so I won't give you an introduction, but I did want to mention a little bit about why he's helping us do today's presentation. As an Appeon MVP, Bruce gets access to insider releases of our products. And he loved the features of PowerBuilder R3 so much that he offered to do 2 community webinars, one focused on the new REST and JSON features, and another one focused on encryption. And since there was a lot of overlap between his webinars and what we'll be doing today, we figured it's best we invite him to give you this preview, as well as you'll get to drill down in deep dive sessions regarding these new features. So without further ado, we'll get today's webinar started. Today's webinar will give you an overview of what R3 will offer if you're upgrading from R2 or older versions of PowerBuilder. We'll also cover the various editions of PowerBuilder that are available, since not all features are available in all editions. And we'll give you a quick tutorial on how to use all of the key new features in R3. And we'll take a hands-on look, which is essentially demonstrations of some of the most interesting features that demo nicely. And finally, we'll open it up to a live Q&A. Bruce and I will be here to answer all the questions that you may have. Now, as we're doing this webinar today, please feel free to ask your questions in the console. You can expand the console on the right-hand side and start typing away. There's no need to wait till the end, but we'll definitely be opening up at the end and answering your questions orally, not just through the question pane. So in terms of an overview of R3, we believe 2017 R3 is a low-risk, valuable upgrade because it is a revision of the time-tested PowerBuilder 2017. PowerBuilder 2017 was brought on the market essentially a year ago, and it's been through numerous maintenance releases and tested by thousands of customers. And also, R3 is a designated long-term support version. Long-term support version is a special version of PowerBuilder, or any of our products for that matter, that Appeon commits to supporting for a long period of time, which is typically a minimum of 3 to 5 years. So that's also further evidence of how stable this particular version is. Now, R3 is the only major version of PowerBuilder that's supported on the Windows 10 and 2016 operating systems. Older versions of PowerBuilder, such as 12.x, are not supported on Windows 10. In fact, Appeon has addressed a number of Windows 10 specific bugs. In addition, you'll get support for the latest database versions, including SQL Server 2016 and 2017. R3 also provides enhancements of some great new features we introduced in R2 about 6 months ago. R2 had added support for Git and SVN through native APIs. It offered enhancements of the native PDF. It introduced a new REST and HTTP client with support for TLS 1.2 security, as well as a number of other expanded functionality compared to the traditional INET object. R2 also introduced support for PostgreSQL and a number of other great enhancements. So what R3 has done is taken what we put out in R2 and improved upon those. We've taken feedback from customers over the last 6 months, and we've now made these features more usable and even in some cases enhanced its functionality and not just the usability. So we're really trying to listen to the feedback of customers and polish our features, not just put out a 1.0 or a 2.0 and then move on to the next thing that interests us. Now, number 4, I'd like to point out that R3 is not just about enhancing the R2 features and also giving you the stability of bug fixes. It's really giving you also some very important new features that paves the way to go to the cloud with PowerBuilder. And a lot of the server-side cloud features are coming in 2018 with C# Web APIs. But we need the client side of PowerBuilder, the apps you're developing for the desktop, to be able to interface with all these great cloud technologies. And to do that, it's really important to support OAuth as well as encryption so that you can do this cloud architecture securely. And so these are 2 key new features that are introduced in R3. Now, in terms of the additions, PowerBuilder is available on a subscription basis that includes a subscription license, updates, and as well as technical support. A subscription is per developer per year, and we offer 3 levels of subscriptions depending on the functionality you're interested in. There's a standard, a cloud, and universal. Now, the standard is almost quite similar to what previously Sybase had branded as the Enterprise Edition. So the point is the standard is very feature-rich, but the key feature standard is missing, which you might be able to tell from the next edition, the cloud, is cloud-related features. So what are cloud-related features? It's specifically the .NET Web Services target and the .NET Assembly target, as well as the C# development that we're introducing in 2018. As I mentioned, C# development will be done for server-side cloud objects. So for example, RESTful web APIs if you want to create those. Simply consuming web services, calling web service, that's in standard. You don't have to pay extra to get that functionality. And then the universal adds more cloud features, allowing you to leverage what's called Power Server Web and Mobile, which is another product that we offer that's been integrated into PowerBuilder so that you can rapidly cloudify your existing PowerBuilder projects with a lot less code effort and get that running in the cloud with a web or mobile interface. Now, if you'd like to learn more about PowerBuilder 2018, we're not going to be covering that in today's webinar since this focuses on R3. Go ahead and visit www.appion.com/pb2018.html. Now, while 2018 is not yet available, that's scheduled for December of this year, you'll be able to get some idea of what functionality will be offered in PowerBuilder 2018, as well as what C# development will be like with PowerBuilder and why it's so fast and easy. Now, the R3 features we're going to be covering in today's session are the enhancements that we've made it to Git and SVN. So again, as I mentioned, these were features that were introduced in R2, and based on customer feedback, we have enhanced these features, as well as we've added some additional functionality related to this. We've also made enhancements to the native PDF, and we've made enhancements to the REST and JSON, so we're going to be covering that as well, and that's going to include a hands-on demo that Bruce will do for you. And then we're going to be covering OAuth, which is used for user authentication and tokens. We'll be covering the encryption features that are introduced, and this is a set of features that Bruce will explain to you, as well as some enhancements we've made to PostgreSQL, and some enhancements we made to the Standalone Compiler, which was actually introduced in PowerBuilder 2017. So we've enhanced this feature 3 times now. Now, the things we're not going to cover in today's webinar, but are included in R3, is development licenses of Power Server Web, support for the REST client for your DataWindow child objects, if your DataWindow childs are going to be powered by REST Web APIs, and then support for SQL Server 2017. As well as some improvements we've made to the cloud license model so that it automatically signs you in and out in case you forget to do so. So now we're going to turn it over to Bruce.
Okay, thanks Armin. Well, the first feature we're going to look at that was delivered in R3 is enhancements to Git and SVN. So the first item here is that the source control login dialogues have been updated. In R2 there was an issue in that a certain naming for the repository was forced on you based on the workspace name, and then for some of the Git providers there was no way to provide the .git extension on the URL that some Git providers needed. So that's been corrected in R3. The URL that you can provide is just a text field, and you can specify anything you want there. In addition, in R3, under the workspace properties, on the source control tab, there's now an advanced button, and that takes you into a dialog that allows you to configure which utility is used to do a show log and which utility is used to do diff viewing for the objects that are under source control. Now obviously if you've got that option, those options become available in the PowerBuilder IDE. So now there's new options available when you right click on an object under source control. There's diff, there's show log, there's also open containing folder. What that's for is if there's something you want to do that is supported by Tortoise SVN or Tortoise Git but isn't supported by the PowerBuilder IDE, you right click, say open containing folder, it takes you to the location where the source code is actually at. You right click on the source code and it will then show you the Tortoise SVN or Tortoise Git dialog, and you can do whatever other operations you need to do that PowerBuilder doesn't directly support. And then finally, this option is only for SVN. There's the ability to do locking. So there's locking, unlocking. Also in R3, we'll just mention these. There won't be a demo of this, but there's no more PBG files. A PBG file is something PowerBuilder used for when objects were under source control to associate the source object to a particular library. Because under the old MSS-CCI interface, the source code was exported into the directory that the library was in, and if you actually had your workspace set up or your target set up so all the libraries were in the same directory, you'd end up with all the source code in that one directory, and PowerBuilder couldn't figure out which went where. Under R3, because PowerBuilder is handling that for you now, it creates its own WS objects folder, and it creates a library for each, file directory for each library. It's able to keep track of the source code just by which directory it's in, and so it doesn't need a PBG file anymore. And finally, there's some OrcaScript changes. There was an issue with R2 because OrcaScript, at least through R2, when it was looking for the source code, as we just mentioned, would look in the directory the library was in. And that's not where it was located with the new drivers. It was located in the WS objects folders. And so with the changes in R3, there's a setting you can provide that says this is where the working directory is at that has the source code, and then OrcaScript can go ahead and do a build from source in R3. So let's go ahead and take a look at this online. So we'll start off with connection to source control. So if I say add the source control, and I'm going to use this version for the example here, notice how this repository URL is just this open field. I can specify anything I want there. So that's the first one. Let's go ahead and change the workspace here to something that's already under source control. So here I have an object that I want to edit. And the first thing I can do is I can go in and say I want to get a lock on it. So now I've got a lock on it, and this little lock icon appears there. I'll go ahead and make a change. I'll change that background color to something else and save that. It's updated to modified. I can go in now and do a diff, and I can see what my changes are between what I've got and what's in version control. This happens to be a source gear diff merge that I'm using here. You can configure it to use any number of diff tools. I can also go in and do a show log, so I can see all the changes that have occurred to this object over time. And if there's something else I want to do, such as look in the repro browser, I do this open containing folder. It takes me right to the folder that's got the source code in it. I right click on the object. I can say Tortoise SVN. I can say repro browser. And this gives me a lot more information than the PowerBuilder IDE does. For example, it shows me who's got what particular objects locked. Now, PowerBuilder will show you that you've got an object locked, but it won't show you that other users have objects locked. And that's one thing this dialog can show you here. So, and then you've got a a release lock as well, in case you decide you don't want to make that change or you want to abandon the change. Also, when you do a commit, you have an option whether or not you're going to keep the lock or not. So the default is to actually release the lock on the commit. So how does the diff and the show log work? We go to the workspace properties. We go to the source control tab. There's a new advanced button, and that brings up this dialog. Now for show log, you've only got one option. It's two. It depends what version control system you're going to use. But if you're using Tortoise Git, if you're using Git, you're going to use Tortoise Git, or if you're using Subversion, you're going to use Tortoise SVN. So in this case, I'm using SVN, so I'm using the Tortoise SVN executable there. The diff viewer, it gives us a lot of options though. So like I said, I'm using diff merge here. The default is to use Tortoise SVN. Like I said, I'm using diff merge. Another one I highly recommend looking at is semantic merge. The difference here is diff merge is free. Semantic merge, there is a cost involved, but semantic merge is very good about handling block code moves. That's something that PowerBuilder does. For example, if you change a function prototype, it will actually reorder the functions in an object. And using a normal diff viewer, that makes it look like a lot more happened than it actually did. And semantic merge actually figures that out pretty well. And then if you don't like any of these tools, if you get something else that you like, you can use this other option, and then you can go ahead and set up the arguments however you need to provide them for that particular diff tool. So that's the SVN and Git changes. Now, a question that comes up quite a bit is, I'm using some legacy version control system, let's say PVCS now, and I'm thinking of moving. I don't know what I should move to. Should I move to Git? Should I move to SVN? Should I move to Team Foundation Server? Well, the answer is it depends. So there's some things you need to consider. Primarily the difference between Git and SVN is Git is a distributed source control system. There's a repository on every developer's workstation, and there's usually a central repository that they all sync up with. What that means is that you can work offline. You don't have to have access to that central server in order to do source code changes. On the other hand, because the Git is not a centralized system, Git doesn't support locking. There's only a couple of vendors that have any kind of locking capabilities. The vast majority of Git providers don't provide any locking capability. Subversion does. And the reason you want to look at locking is if you want to avoid merge conflicts. You don't want two developers both working on the same object at the same time and checking in their changes one after the other, and whoever's the second one in ends up with a merge conflict because they've got some overlapping changes. Something to keep in mind though is with Git, Git is a lot more flexible when it comes to doing a merge. What it apparently does is it looks at each line of code, and if the same developer, if the same line isn't modified by both developers, it doesn't consider it a merge conflict and goes ahead and does the merge. Subversion is a lot more, it looks at blocks of code. And so if two developers make changes and they make it to different lines, but those lines are in the same block of code, Subversion is likely to throw up a merge conflict that you'll have to resolve. So that's something else to keep in mind. If you don't think that you're going to have same developers working on the same line of code, you probably could use Git and not worry about the merge conflicts because they won't happen. The problem being, obviously, if they do edit the same line, then you're, regardless of which system you're going to use, you'll get a merge conflict unless you've used locking and Subversion to prevent that from happening in the first place. The other thing is data windows. Data windows basically look like a few very long lines of text to any diff tool. And so what happens is one developer could modify one piece of a data window, another developer could modify another piece of a data window, but it'll end up throwing up a merge conflict because to the merge utilities it looks like a single line. So as we mentioned before, because Subversion doesn't do the merging quite as well tends to throw up merge conflicts more often, it does support locking. So that's an alternative for you if you're going to want to use SVN instead. Something that applies to both systems is that binary objects, let's say images, can't be merged. If two developers make a change to binary objects, with the exception of the Pibble, you will get a merge conflict, and you have to decide which of the two that you're going to accept. There's no way to merge a binary object change. Last item here has to do with Team Foundation Server. If you look at the modern Team Foundation Server, what you'll actually see is that there's two different version control systems in use there. One is TFVC, the Team Foundation Version Control, the old Visual Source Safe. The other one is, the newer one, is actually Git. Microsoft provides Git in Team Foundation Server. In fact, if you start a new project in Team Foundation Server, it will default to Git, and you actually have to take an extra step to make Team Foundation Version Control the version control system. It's also worth noting that Microsoft just bought GitHub, which is basically the planet's largest Git repository. So Microsoft is making a real push towards Git, so that might be a clue which direction you might want to head as well. So that's enough about Subversion and Git. Let's look at the next R3 feature. That's in NativePDF. There were actually some enhancements in R2 worth mentioning. That was the ability to specify the image format that's used in the files, the print specifications that are used during the generation, whether it's the ones in the data window or ones in the system settings, and then finally the PDF standard that's in use. That becomes particularly important because a lot of the R3 features, whether or not you can use them, depends on which PDF standard setting you're using. Now the default setting is 0, which they indicate is none. That's a little bit of a misnomer. The other settings in the PDF standard are subsets of the PDF standard. The issue is that in the full PDF standard, you can do a lot of things that are not considered great as far as security. For example, you can embed Flash, you can embed JavaScript, you can embed references to other PDF files. These other PDF substandards were introduced to provide more secure versions of the PDF standard. So those prohibit some of those features. But for the features we're going to look at for R3, you do have to have it set on the PDF standard of 0 for most of them to work. The three in particular are the user password, the master password, and restrictions. All three of those require that you have the PDF standard set to none. The next one doesn't matter which way you have it set. That's the ability to do SaveNativePDFToBlob. That's a function, new function. So we're going to look at the R3 changes here. So if somebody sends you a PDF document, you open it up and it prompts you for a password, that indicates that they've set a user password. My text preparer does this when they send me my return, because they don't want anybody besides me opening up that PDF document if they happen to get a hold of it. And so you can do that for your files as well. You can set a user password. Now, when you set a user password, you also have to set a master password. That's how the PDF reader knows whether or not you're trying to open this as the recipient or as the author having full rights over the PDF file. So you set two passwords, and then when the password prompt comes up, which one of those you provide indicates whether you want to open it up as the limited user or as the author. Now the reason I say limited user we'll get into in a minute is because of restrictions. So here's the master password. If you have to set it if you set a user password, and you also have to set it if you do restrictions. And of course you can do both. And it must be different than the user password. The reason being is that the PDF reader only throws up one password prompt, and it looks at the response to determine whether you gave it the user password or the master password. The last item here is restrictions. So if you go into a PDF document, and you go to its properties, go to the security tab, hit show details, this dialog pops up, and this will show you what features of the PDF file have been disabled by the author. Now in this particular case, I basically disabled everything. I don't allow printing, I don't allow document assembly, copying the contents, extracting pages. I've locked down the document basically as much as I possibly can. The restrictions property is a comma delimited string of the restrictions you want to apply. So there's a different keyword you use for each one of these settings that I've turned off here. If you don't provide anything, of course, it's available. It's what you provide, what you indicate in the restrictions is what you want to turn off. And then finally, we have the SaveNativePDFToBlob function. Now, what this is for is if you wanted to, let's say, create a web service that streams a PDF file down to a client. Now, up through R2, to do that, what you would need to do is you'd have to write out the file. Write the PDF as a file to the file system, and then read it back in as a blob, and then send the blob down the wire. Now, the problem with that, well, one is slow. The other one is, though, is it requires the service to run under a user account, and the user account being granted permissions to write to the file system. That's really kind of obtrusive method of deployment. It'd be much better if we could just, get the source code, the source for the PDF file directly into a blob and send it down to the pipe without having to go through the file system. And that's what this function does for us. It allows us to grab the PDF source without having to go through the file system. So that's the PDF enhancements. I'm not going to demo those for today's session. We're going to look at REST next. And in REST, there's two categories of changes. There's enhancements to JSON, and then there's the new OAuth capability. So with JSON, there's actually been two JSON formats that are now supported. The first one is called Simple JSON, and that's the JSON that you typically see anytime you're dealing with JSON. It's name-value pairs. If it's coming from a data window, it's going to be an array of name-value pairs. Other sources might provide structures of those name-value pairs and arrays of structures, that kind of thing. The other format is called Standard Data Window JSON. Now, what that is, it's not just the data; it's metadata about the data. It tells you the data window name that the JSON was generated from. It tells you the row status information of each row. It gives you column status information of each column. It gives you the original and modified values if there's been a change to a column value. Basically, it's everything you need to know about the data in order to send that data up to, let's say, a server component, and have the server component import it and apply the updates as if the changes were made on the server. It's the ability to do distributed updates. It's in the old distributed PowerBuilder days, we had a set of functions called setFullState, getFullState that did this same thing. The client would allow the user to make changes. It would run a getFullState to bundle those changes up, send them up to the server component. The server component would do a setFullState into a data window and then issue the update. And all the changes that the user had made on the client were then applied through the server component. This gives us the same capability to do this with REST services using R3. The difference, though, the issue with the old getFullState, setFullState is that what was sent was a blob that had a proprietary format, and you couldn't look at the blob and see what the data was. With the standard data window JSON, we're using an internet standard, the JSON, and it's open. You can look at the data and you can see what's being sent up. Okay, so this is an example of what standard data window JSON. This is not exactly what it looks like, but this is the structure of it. So it has an identity, a version, the data object, the name of the data window object that was used, the information about the columns. Here's your primary filter and delete rows, which are basically the buffers, and also data window children. So if there's any data window children in the data window, it will actually have the data for those as well. And then for each row in here, you've got a row status. For each column, you have a column status, and like I mentioned before, original and modified values. So how do you get the data out of the JSON out of the data window? Well, there's one function, but there's a whole bunch of different ways to call it. It's export JSON. The Boolean format that's on all of these is the indicator of whether you want the simple JSON or the data window standard JSON. So this first version is just going to grab all the data in the primary buffer and give it to you in one of those formats. The second version allows you to specify the buffer that you want the JSON for, the data out of. And then the changed only indicates that you only want changed rows or you want all the data. This third one allows you to specify via flags any or all three of the buffers you want the data out of. Well, actually, and then for the fourth one would be the data window children. And then finally, this last one, this fourth one, allows us to specify the buffer, but also allows us to specify the start row, ending row, and even start column, ending column, in case there's only a certain subset of the data that we actually want to export. So that's how we export the JSON. How do we get it back in? Well, we do that through the import JSON function. Now that takes, there's only one argument that's required. That's the string of JSON. You might be asking, where's that Boolean format? Well, the data window is pretty smart. It figures out when you hand it the JSON whether it's the standard data window JSON or the simple JSON. So you don't need to tell it that. There's a argument you pass by reference here. It's a string which will return error information to you, kind of like the old data pipeline did. There was a string you passed by reference, and you would get back the any error information that occurred during the pipeline. So this is the same thing, but for the import of the JSON. You can specify a particular buffer that you want to import the data into, and then you have the ability to specify a start row, end row, start column, end column, in case there's only a subset of the data that you actually want to import. And there's also a DW start column in case you want to shift the data over a little bit. So that gives us the ability to import and export the JSON. This next function gives us this ability to batch up JSON data sets. The reason we want to do that is because REST calls are actually a fairly expensive operation. And so if you've got a window, let's say, and you've got 4 data windows on that window, instead of making 4 REST calls to populate the data, what you would, from a performance standpoint, what you want to do is you want to make 1 REST call and get all the data in one call, and then populate the 4 data windows. And so we do that is through a JSON package object. What that does is allows us to have the server component batch up all 4 data sets, send them down as a single JSON object, and then on the client side, the client can go through and pull out the individual data sets. So how does that work? Well, there's actually 4 functions involved here. The first one is set value. So let's say you've already exported the JSON from the data window. You would use this first version. Then the key is the name of the data set, just whatever name you want to give it. So maybe you've got employees and you've got departments. So you would pass in, let's say employees here for the key, and then the JSON that you've already extracted for the value. Alternatively, if you haven't extracted the JSON yet, you can let setValue do that for you. So you just say setValue, the name of the data set, and then either the data window control or the data store that you want to have the JSON extracted from. So you do that multiple times. That gives you the combined data set, and then what you do is you use either getJSONBlob or getJSONString to get that combined data set out into something that you can send down the wire. You send that up to or down, let's say from the server down to the client. The client then can then use this loadString method. That takes that big combined data set of data sets, and it moves it into the JSON packager, and then you use getValue, and so this would be like employees, to get one particular data set back out of that combined data set. Okay, so let's go take a look at that hands-on. Let's take a look at JSON. So this happens to be the Booktown database sample that I use for my PostgreSQL demos. And so it's got a list of titles of books here. So I do a simple export, and you notice it's just the data and the name value pairs, and then the indicator that we have an array of them there. So that's simple JSON. Now let's look at the data window standard JSON. Okay, so now we've got a lot more information. So primary rows, there's no filter or delete here because I haven't made any changes or filtered anything. And I haven't made any changes, so you don't see you see the row status indicators, but you don't see much else because I haven't made any changes here yet. But that's the DataWindow standard JSON. Now let's import that back, and to prove there's no smoke and mirrors going on here, the first thing I'm going to do on the import is clear this data window out, and then I import this right back in. Yeah, and so then there's the data. So that's the import working. Let's do a merge. Now for the merge, what I'm going to do is I'm going to take the title information here in this data window, and then there's author information that's in a data store object, and I merge those together. So here's the books. That's the key I gave it for this data here. And if we scroll down a little bit farther, there's the authors that came from the data store. Okay. And then that would be sent either up or down the wire, whichever, if you're doing updates, you're going to send it back up the wire. And then you can do the extract. I'm going to extract just the author information. So now the book information went away. This is just the author information. And there's no authors out here because that was the key value. That wasn't actually part of the data. This is just the data for the from the author's data store. So that is JSON. So let's go back to the slides. And let's look at OAuth. Now what OAuth is, it's pretty much the standard for doing authentication for REST web services. And so it's now supported through an OAuth client object, which is a new object. It's also been the REST client and HTTP client objects that were introduced in R2 have also been updated to support this as well. So for the OAuth client, the methods are access token and resource request. So what happens with OAuth is that you usually have an ID value and a key, and you send that up in a token request. You get back a token. What you then do is on this request resource is you call that over and over again from then on. You don't keep asking for the token over and over again. Once you've got the token, you only need to do that once, and then you just keep doing these request resource calls. You can do that up through the lifetime of the token. So it depends on which web service you're calling, how long the token's good for. In the demo I do of this, I use Twitter, and Twitter actually doesn't expire the tokens. You can, once you've got a token, you can keep using it forever. Now, as I mentioned, the REST and HTTP client were also modified to support this, so that you can take that same token request object, and instead of giving it to the OAuth client, you can use it in the call for either REST client or HTTP client. REST client being the method that's used to retrieve data directly into a data window. HTTP client is used in PowerScript if the data is a little more complex and you want to parse it before using it in data window or wherever you're going to use it. So in the retrieve method, this is optional. You pass the token request. In the HTTP client, it's in the send request. You can send a token request. Now, this may look like it's going to send that token request on every argument. It's not. What PowerBuilder does is once you send in a token request, it will cache the request and the token it got back. And so if you make another token request, it will compare the ID and key values and the URL that you're doing this request for, and if it finds that request has already been sent and you've already got a token for it, it will just use the token it's already got. It won't send the token request again in subsequent calls. Okay, if you're interested in seeing the live demo of that and really taking a lot deeper dive into the JSON and OAuth, I am going to be doing a separate session on JSON and OAuth on September 5th, 2018. It'll be at 9 a.m. San Francisco time. And there's a URL you can use to register for that. So next item is encryption. Now encryption is a rather broad term that actually includes more than just encryption. It actually includes encoding. Then we've got the symmetric and asymmetric encryption. We also have asymmetric signing and hashing. Okay, so encoding, there's actually 3 different encoding methods that are supported. Hex, both encode and decode. Base64 encode and decode, and then there's URL encode and decode. Now one thing to keep in mind for all these functions is that they take UTF-8 encoded blobs, and they return, if they return some value, they return UTF-8 encoded blobs as well. The reason that's worth mentioning is because if you take a string argument in PowerBuilder and you just apply the blob function to it, what you will get back will not be UTF-8, it'll be UTF-16LE. So you can't just apply the blob function or the string function to a blob and get back the data in the appropriate format. You need to actually specify that it's UTF-8 you want when you do the conversions. So next is symmetric encryption. So there's a new cyber object. It has an encrypt and a decrypt method for symmetric encryption and decryption. There's an algorithm. There's several different algorithms you can use. The variable is the data that you want to encrypt or decrypt. The key value is the key you're going to use for the encryption or decryption. It's the same value for both encrypt and decrypt. That's why this is called symmetric encryption, because it uses the same key for both. And then these next three arguments all depend on which algorithm you're using. Some of them require an operational mode, some of them require an IV, some of them require padding. Basically, you need to look at the help and see that, for this particular algorithm, which of those you need to provide. Then there's asymmetric encryption. Now, once again, there's two methods, an encrypt and a decrypt. There's an algorithm. Once again, there's a variable. This is the data that you're trying to encrypt or decrypt. But now there's a public and private key. Now this is different. With the symmetric encryption, the key could be anything, any value that you just decide to use. The public key and private key used for asymmetric encryption, though, are related, and there's certain algorithms you need to do to create those keys in order so that anything encrypted with the public key can be decrypted with the private key. So that's why it's asymmetric. It's two different keys being used, and it does take a little bit more work to get the key values. So how do you get those key values? Well, there's a lot of different ways to do it, but actually PowerBuilder gives you one. There's a asymmetric generate key method. It takes an algorithm, it takes a length of the key, 1024 bits or 2048 bits. And then these next arguments are actually passed by reference. These are the keys that are being generated. And then so the algorithms are RSA, DSA, and Robin. Now DSA isn't used for asymmetric encryption. It's used for asymmetric signing, which is our next topic. So for encryption, you can just use RSA or Robin. For signing, you can use all three. So here's asymmetric signing. Now the difference, it may look the same. You've got an algorithm, you've got a variable, and you have a key. The difference is encryption helps ensure that the data isn't observed while in transit. Because it's hidden, it's scrambled basically, and only the person that has the appropriate key can unscramble it. But what it doesn't do is it doesn't verify that the person who sent the data to you is the person you think is sending the data. This could be somebody else. Somebody could send you encrypted data, but it could be somebody else that's sending it masquerading as the person you're expecting the data from. What signing does is it provides that authentication that the person who sent this data is the person I'm expecting the data from. Notice that the keys are essentially reversed. For signing, you use the private key to sign and the public key to verify the sign. So what happens is you'll sign the data, you send it down to the user, and then the user will use the verify sign to verify that you are indeed the person who actually sent the data. And then finally we have hashing. Now hashing is a one-way operation. It's not like encoding and decoding. There's basically three different methods used to do it: MD5, HMAC, or SHA. And what it does, it's like a checksum. And you might notice if you go to download a file someplace, they will have a link to the file, and you'll often see let's say an MD5 or maybe a SHA or HMAC string. What that is that's something you can use so that when you download the file, you can calculate the hash code for that file and compare it to the hash code they say that the file should have. And if you don't get a match, it means the data got corrupted somehow during transit. So that's what this is used for. It's a one-way operation. You can't take a key and somehow unhash it and get the data back. It's just an indicator that the data you did get was accurate. So that is encryption. We're not going to do hands-on today because I'm going to do another webinar, a much deeper dive, on September 18th, 2018, once again at 9 a.m. And there's a URL that you can use to register for that as well. So, next feature, well actually the next two features are kind of short here. First one is PostgreSQL. That was largely complete in R2, but the one issue that we had in the database painter when you're working with the database was that the only thing that was supported was views, tables, and then functions and procedures. And even when you got the tables, there wasn't really support for doing primary keys or indexes or anything like that. That's been beefed up now. If you look at the PB ODB 170.ini file, there's a whole large section now. That's the file that PowerBuilder looks at to see how it's supposed to interact with that ODBC database. And so there's a whole big section in there that tells it what syntax it's supposed to use to do these operations. So now there's a lot more you can do with the tables. You can actually manage users, groups, do a lot more through the database painter. Last one is the Standalone Compiler. That was largely feature complete in R2. There was one little issue with it. In the original 2017, only a few of the options that were available in this project painter were available. R2 really got almost all of those. The only problem is that this product version for the installer, this for numeric values, you couldn't set that in R2. And also the same value was used for this, the file version, and the string value, and the file version number value, which means you could only provide a number because if you provided a string, it wouldn't work here. And so what they did with R3 is they just went ahead and split those up into 4 separate arguments. Now you can set them all each individually. So that pretty much finishes up what was missing in R2. Okay, so that's all the R3 features I'm going to cover. I'm going to turn things back to Armin now for the question and answer session.